So this is the 2024 Higher Level Applied Maths Leaving Cert paper question 9. A geologist is carrying out a survey of an opal mine. During the first month of mining, a mass of 200 kilograms of opal was removed. During the second month of mining, a mass of 245 kilograms of opal was removed. The geologist predicts that M, the mass of opal removed in any month, can be expressed by the second order homogeneous difference equation Mn plus 2 is equal to Mn plus 1 plus 3Mn over 4. N is positive or equal to 0, an integer. M0 is 200, M1 is 245 kilograms. Write down the values of M2 and M3. So the equation that we have is Mn plus 2 is equal to Mn plus 1 plus 3Mn over 4. We want to work out M2. So that would mean that if N plus 2 is 2, N must be 0. So we have a 0 here. So this is actually M1. So M1 we know is 245 plus 3 times Mn. Well, we've worked out that N is 0, so we need M0. We know that M0 is 200, so it's 3 times 200 over 4. When you do that, you'll get 395 kilograms. We just got to do this again for M3. So M3 is equal to, so if this is 3 here, that means N must be 1. So we want M1 plus 1, in other words we want M2. So M2 is 395 kilograms plus 3 times Mn. We want M1, and M1 was 245. Divide by 4. When you do that, you get 578.75 kilograms. And that's really it for part 1. Okay, so let's have a look at part 2. Solve the difference equation to find an expression for Mn in terms of N. Okay, so our difference equation is Mn plus 2. I'm going to bring everything over to the left hand side, so it's Mn plus 1 minus 3 Mn over 4 equal to 0. So we've got to write down our characteristic equation first. Our characteristic equation, I'm going to use x here. This is going to be our x squared. This is the x, and this is the constant then. So it's just 3 over 4 is equal to 0. So we've got to solve this. So I'm just going to multiply across by 4. 4x squared minus 4x minus 3 equal to 0, and we'll do our factorizing. So it's going to be 2x times 2x, and then we've got 3 times 1, it's plus times minus. That'll give me x is equal to minus a half and 3 over 2. So these are my two values. This is actually alpha. This is alpha and beta, which I'm going to put into solution. And our solution will be in the form Mn is equal to L times alpha to the power of n plus m times beta to the power of n. So let's just put those in. So what we'll end up with is Mn is equal to alpha is minus half to the power of n times L plus 3 over 2 to the power of n times m. Now we've got to work out what L and m are. So in order to do that, we're going to form simultaneous equations using the information we're given. We're given that m0 is equal to 200. So if m0 is equal to 200, we're going to put 200 in here. That'll give us minus a half to the power of 0 L plus 3 over 2 to the power of 0 times m. That'll simply leave us with 200 is equal to L plus m. These are just equal to 1. Okay, so this is equation number 1. Let's do equation number 2 then. So we're also told in the question that m1 is equal to 245. Let's do that one. So 245 is equal to minus a half to the power of 1 L plus 3 over 2 to the power of 1 m. Okay, let's just simplify this a little bit. So we have, let's see, 245 is equal to minus L over 2 plus 3 m over 2. That'll give us, let's see, I'm just going to multiply across by 2. That'll give me, let's see, 490 here minus L plus 3m. This is equation number 2. Let's just put equation number 1 underneath it there and add them. So equation number 1 was, let's see, L plus m, and it's 200 on this side, so it's L plus m. So if we do that here, we'll get 4, 5, 690. The L's will disappear and we'll get 4m. That'll give us an m value of, let's see, 172.5. So that's our m. All we've got to do now is put that into one of the equations to find what L is, and that'll give us our final solution. So let's see, I'm going to just move over here a little bit. We have equation 1 was m plus L is equal to 200. So we've just worked out that m is 172.5 plus L is equal to 200. That'll give me an L value of 27.5. Okay, so we have L and m. That'll finally give me our final solution here of minus a half to the power of n times 27.5. That's our L that we've just worked out, plus 3 over 2 to the power of n, and we worked out the L value of, or the m value I should say, of 172.5. And that's our solution. I mean, you can check that by putting in 1 and 2, or 0 if you like, is probably the easiest one. If you put in 0 here, you'll just get 1. If you put in 0 here, you'll get 1. If you add 27.5 and 172.5, you will get m0, which was 200. So it does seem to work. Okay, so that's it for that part. So in part 3, we have to calculate the total mass of opal that is predicted to be removed during the first 6 months of mining. So we already have some of these months. We have M0, which was 200 kilograms. We have M1, which was 245 kilograms. We have M2, which was 395 kilograms. And we have M3, which was 578.75 kilograms. So what we've got to do is work out M4 and M5. We know that Mn is equal to minus a half to the power of n, 27.5 plus 3 over 2 to the power of n times 172.5. So really all you've got to do is put in 4 and 5 into that equation. So M4 is equal to minus a half to the power of 4 times 27.5 plus 3 over 2 to the power of 4 times 172.5. When you do that, you should get 875 kilograms. You do exactly the same for M5. I won't write it out, but you should get 1309.0625 kilograms. By the way, when you have to do something like this and stick different values into the same formula, on some calculators you can just leave that on your calculator, scroll back and just change the powers and press equals, and it should give you the new answer. So let's see, we just got to add all of these up. So the total opal removed during the first 6 months is equal to 200 plus 245 plus 395 plus 578.75 plus 875 plus 1309.0625. So when you do all of that, you should end up with 3602.8125 kilograms. And that's really it for part 3. After the government introduces stricter mining laws, the geologist changes their predictions by estimating that the mass of opal mined in month n will be reduced by 2 to the power of n kilograms. The geologist predicts that P, the mass of opal removed in any month, can now be expressed by the second order inhomogeneous difference equation. Pn plus 2 is equal to Pn plus 1 plus 3 Pn over 4 minus 2 to the power of n plus 2. Again, n is positive or equal to 0, an integer. P0 this time is 199, P1 is 243 kilograms. Solve this new difference equation to find an expression for Pn in terms of n. Okay, so this is the same as what we did previously, but this time we've got an inhomogeneous difference equation. So this second half of the question is going to be the same as the first almost, but just a different type of equation. So let's start it anyway. We have Pn plus 2. I'm just going to bring over the Pn plus 1. I'm going to bring over the 3Pn over 4, and that's equal to minus 2 to the power of n plus 2. So we have this part of the equation which we've already done in a previous part, and we have this part here is new. So I'm going to look at this part here first. We're going to look at the particular solution. So our particular solution, I'll call it Pn, is equal to a constant times 2 to the power of n. You can see here we've got a 2 to the power of 1 times 2 to the power of n, so this is k 2 to the power of n is what I'm going to be looking at here. So this is our particular solution. I've just got to write down Pn plus 1 because we've got a Pn plus 1 here. That's going to be equal to k times 2 to the power of n plus 1, which is equal to, let's see, this, if we split this up we'll get 2 times 2 to the power of n, so we end up with 2k 2 to the power of n. Now if we look at Pn plus 2, put in here, this will be k times 2 to the power of n plus 2, so that's equal to k times 2 to the power of 2, 2 to the power of n, so that's 4k 2 to the power of n. Okay, so we have our Pn plus 1, and our Pn plus 2. So let's put those in here. So our particular solution then will be 4k 2 to the power of n. That's this one here, that's here, and that's here. So that's minus this one here, which is Pn plus 1. So that's minus 2k 2 to the power of n, then minus 3 over 4 Pn, which is this one here, that's k 2 to the power of n. All of that is equal to minus 2n plus to the power of n plus 2. So we just got to work out what k is from this. So the first thing I'm going to do is I've got a 4k 2 to the power of n's, and I've got minus 2k 2 to the power of n's, and I've got minus 3/4 k 2 to the power of n's. So I'm just going to combine these three here to give me 5 over 4 k 2 to the power of n's. That's equal to minus 2 to the power of n plus 2. Next thing I'm going to do is I'm going to divide across by 2 to the power of n. So I've got 5 over 4k is equal to minus 2 to the power of n plus 2 divided by 2 to the power of n. I've got 5 over 4k is equal to, here I've just got to subtract the powers, so I get minus 2 to the power of n plus 2 minus n, so that just gives me minus 2 squared. All I've done is subtracted the powers here. So next thing I've got to do is divide across by 5 over 4. So k is equal to minus 4 times 4 over 5, or just k is equal to minus 16 over 5. Okay, so I have k now, so what I've got to do now is write out the particular solution. Remember, we started up here by saying the particular solution is Pn, which is k times 2 to the power of n. So I'll just put in my k here, and that will be my particular solution. So that means my particular solution is equal to minus 16 over 5 times 2 to the power of n. This is my particular solution. Okay, so that's our particular solution, and now what I want to do is just write down the complementary solution. Now we've already done this in a previous section. We got Pn is equal to minus a half the power of n times L plus 3 over 2 the power of n times m. Now we worked out the L and the M in the previous section, but now we have different P0s and P1s. Now P0 is 199, P1 is 243, so we're going to have to work out what L and M are. The final solution is going to be the particular solution and the complementary solutions added. So let's add those. So Pn, our final Pn, here is equal to minus a half to the power of n times L plus 3 over 2 to the power of n times m minus our particular solution, which was 16 over 5 times 2 to the power of n. So this is our solution here. We've just now got to work out what L and M are, similar to what we did in an earlier section. So we're going to use the two bits of information that we were given. We were told that P0 is equal to 199. So in other words, 199 is equal to minus a half to the power of 0 times L plus 3 over 2 to the power of 0 times m minus 16 over 5 times 2 to the power of 0. So when you work this out, you've got 199 on the left hand side, this just becomes 1, so you end up with L, this just becomes 1, so you end up with m, and on this side you end up with 16 over 5, this just becomes 1. Just going to bring this over to this side here. That will give me, so multiply by 5, divide by 16, it'll simplify to 1011 over 5 is equal to L plus m. Now just get rid of that fraction, 5L plus 5m. So again, this is my first equation. I've now got to work out another equation using P1. So we know that we were told in the question that P1 is equal to 243. So this time 243 is equal to, again, minus a half to the power of 1 this time, times L plus 3 over 2, again to the power of 1, times m minus 16 over 5 times 2 to the power of 1. So we just got to simplify this. This will give us our second equation. So let's just simplify this a little bit. Let's see, we've got 243 is equal to minus L over 2 plus 3m over 2 minus 2 16s 32 over 5. So what I'll do next is bring this over to this side here. That'll give me, let's see, 1247 over 5 is equal to minus L over 2 plus 3m over 2. What I'm going to do next is just multiply across by 10, I think. So that'll give me, let's see, 2 times 1247 on the left hand side, that's 2494. And then here I'll end up with, let's see, minus 5L. And here 2, 10, 3, I'll end up with 15m. So this is my second equation here. So what I want to do is put these two equations together and just work out what L and M are. Now happily enough there's a plus 5L and a minus 5L, so I'll just put equation 1 underneath this here. So it is 1011 is equal to 5L plus 5M. This is equation 1. So we're just going to add these two and we should get a value for M. So when you add these two, you get 3505 is equal to 20m. Finally we get m is equal to 175.25. So let's just write down L plus m is equal to 1011 over 5. This is equation 1 here. I'm just going to put m in here, work out what L is. So we have, let's see, L plus 175.25 is equal to 1011 over 5. That'll finally give me an L value of 26.95. So now I can substitute M and L into our solution. So our answer then, if you like, is Pn is equal to 26.95, that was the L that we just worked out, minus, I'm going to use decimals here instead of fractions, so it's 0.5 to the power of n, plus 175.25 times 1.5 to the power of n, and then minus 3.2 times 2 to the power of n. And that's it for this part. So in part 5 we have to calculate the total mass of opal that is now predicted to be removed during the first 6 months of mining. So this is the same kind of question we had in an earlier section. It's just that this time we've got a different formula. So the formula we're using now is the one we've just worked out, which is Pn is equal to 26.95 minus 0.5 to the power of n plus 175.25, and we have 1.5 to the power of n minus 3.2 times 2 to the power of n. Now we've got to work out P2, P3, P4 and P5. Not sure why they're asking us to do this 4 times anyway, for 6 months. If you can do this once, you can do it a million times, but anyway, it's easy marks I guess if you have the formula here. So let's do, we know P0 is equal to 199 kilograms. We were given that in the question. We were also given P1 is equal to 243 kilograms. So what we've got to do is work out P2, P3, P4 and P5. It's really repetitive stuff. So let's just stick in 2 into our formula. It's 26.95 times minus 0.5 to the power of 2 plus 175.25, 1.5 to the power of 2 minus 3.22 to the power of 2. When you work that out, you should get 388.25 kilograms. Now again, if you have this typed into your calculator, you can leave it there. Just scroll back and change the powers rather than typing the whole thing in again and again and again. So I'm not going to do it out again for P3, P4, P5. I'll just give you the answers that I got. P3 was 562.5 kilograms. P4 I got 837.6875 kilograms, and P5 1227.5625 kilograms. So you've got to work out the total then again. So you just add up all those numbers, and what I got was 3,458 kilograms of opal. And that's it for this question.